Hi all, welcome to Deep Learning by First Principle. My name is Raju Gopal. So in this video we are going to see about a computational graph. Okay. So first we will see what is computational graph. Okay. So computational graph. Okay. Computational graph is a visual representation. Okay, computational graph is a visual representation of mathematical operations. Okay, so computational graphs are nothing but a visual representation of mathematical operation. Okay, so if you already we know, so this is simply a neural network. Okay, simply a neural network. Okay, so two neurons. Okay, one one hidden layer, okay, one output layer. So this is completely connected. Okay, this is completely connected. So this is the simple neural network. Okay, but what is this? Okay, this is the representation of neural network. Okay, so but what is this computational graph? Okay, so computational graph, so neural network represents only the layers. Okay, only the layers, but the computational graph represent additional information about the each and every we can say each and every mathematical operation. Okay, now we can define simply a output layer. Okay, first I will come from the reverse, then we will go. Okay, this is simply output layer. Okay, here. Okay, so this is our last function. Okay, this is output layer. Okay, and so this is our output. Okay, this is our output. This is our output. Okay, so then here this is our actual output. Okay, this is the calculator output. Okay, this is the calculator output. Here we will get, so this is our actual output. This is D. We will say this is D. So this is, now we will say y minus D. So this is our loss or error. Okay, we can say this is our error. So this is our loss. Okay, so this y minus t simply. Okay, so before that, so you see, so this is our first representation. Okay, this is our first representation. So next you will see here. So in this layer, so next this is a one single hidden layer. Okay, so here you have one bias B. Okay, so then this is one, we have one input. Okay, this is our one input. Okay, so this is our one input. This is ix input. Here this is a weight. Okay, so here the linear transformation. So here we will use our activation function is simply multiplication of unit. Okay, multiplication of 1. Okay, so this is our activation function. So our activation function is nothing but okay, so this is activation function is, so simply multiplication of so input ix into w plus b, so into 1. So this is our a simple activation function. Okay, so from this activation function, okay, so this is unit multiplication. So this is the unit multiplication activation function. Okay, this is the unit multiplication activation function, simply 1. Okay, simply multiply by 1. Okay, so this is the, so okay, this graph give us only the what I say, the layer representation of the neural network. But we want to know each and how do the calculation. Okay, what is the value at each and every operation, how does it go in the forward loop, and how does it the in this, okay, so what I say, that the grads are following in the backward. Okay, so backward propagation. Okay, so the backwards propagation. So that's also we can see by using the computational graph. Okay, by using the computational graph. Okay, so we will see here we will see So this is our final output, a computational graph. Okay. So now we will see how to achieve this computational graph. Okay. So first we have to use to produce this kind of graphs. We have to use a Python library. Okay, that is a graphics. Okay. So by using this graphics, by using this graphics, in this graph there are two kind of graphs are available. So okay, one is digraph, one is directional graph, another one is a graph. So first what we are seeing, this is a directional graph. Okay, so if you change this one to only graph, so control is set. Okay, so this is the graph. Okay, so we will get that. So now the direction is gone, but we don't need, so in our case we need only the director graphs. Okay, director graphs. Okay, so we will enter, so we'll get the director graphs. So this is a hello world. Okay, so first we will just put a node alone. Okay, a node alone. So if I remove this label, okay, so if I remove this label, you can see only the name of the node. Okay, so if I give label, if I give label hello, if I give a label g dot node, if I give a label, so now here the name hidden. Okay, the name is hidden, and now we can see only the label. Okay, so but we are using this name for the node connections. Okay, for this edge connection, sorry, for this edge connections. Okay, so we will define our another node. Okay, we will define our another node. Okay, we are defining our another node. Now we will see our another node. Okay, so this is simply a record. So if you using the record, so in the pipelines it make the splitting. Okay, splitting these boxes. Okay, so every box, so we have a split. So this is a record. So if you don't give this record, okay, then this will be a simply a shape. Okay, there is lot of shapes are available, so you can see, so all these shapes we can use, but we need this record and a default shapes, you know, for in our use case. Okay, okay, in our use case. Okay, so this is our second node. Okay, this is our second node. Save this record, set to enter G. Okay, this is a hello world. Okay, then we are going to connect this node. Okay, then we are going to connect these nodes by a edge. Okay, so because this name is 456, so 456, so we will get only one representation. Okay, so I change this name, now you can see we have a two nodes, hello and hello world. Okay, 1 2 3 4 5 6. If I didn't give this edge connection, we can see the nodes without the edge. Okay, without the edge. Okay, without the edge. Okay, so you see that edge is, now we will get the direction. Okay, 1 2 3 2 4 5 6. If I change this one 4 5 6 2, the flow is reversed. 4 5 6 2 1 2 3. Okay, 4 5 6 2 1 2 3. Okay, so this way we will get that. We can see this graph. Okay, so next what we are going to generate a this object class. Okay, so we are going to generate this. So this is the already we have seen. So this is our okay, this is our neural network. Okay, this is our neural network. Okay, so in this neural network, okay, so in this neural network, okay, in this neural network, This is our neural network. Okay, in this neural network, okay, so we are representing this simple equation. Okay, so now we need a object. Okay, object to store all these operations and all these variables. Okay, all these variables. So for that we are making a object. Okay, that object should be a recursive object. It should be okay, that object binds all its operations, all its labels, all its value, and all its previous objects to produce a current object. Okay, that is our purpose of this class. Okay, so first we will see this class. Okay, this class first I will define CLASS class value 1, because already value 1 class is there. Okay, so here I am going to define my init int. Okay, int SCLF self. Okay, self and data. Okay, self and data. So now self dot data equal to data. Self dot data equal to data. Okay, so we will see. Now I am going to visualize. Okay, so a equal to value 1, value 1, value 1 of 10. Okay, value 1 of 10. We will see. Okay, sorry, self in self dot data value val class value 1. Sorry. Okay, the one thing I'm just missing. Okay, so this is our. Okay, so now we are going to see our. Okay, this is my object. Okay, so this is my nested object going to have all the operations, labels, and everything. Okay, so first, okay, then I want to represent this object. Okay, now I can see only the object name and the object memory location. So now I am going to use a magic method, definition of underscore repr double score. Okay, so double score last time I missed. Okay, representation of double score CLF self. Okay, self here retr return. Okay, a function of value. Okay, value. Okay, value data equal to self dot sclf self dot data. Okay, self dot data. Now we will see. Now we will give a decent representation of our object. Okay, so then, okay, then we are going to add a simple addition operator. Okay, so this is also magic. Okay, this is also a magic operator. Okay, here self. Okay, so here there's a two parameter, one is self, another one is other. Okay, so other is also same a value 1 object. Okay, so here we have started our our recursive or our that nested data. Okay, so here we have started to hold the, because in the same object we are using the same object. Okay, so next. Okay, so this is out. Okay, so this output is nothing but value 1. Okay, value 1 of self dot data plus other dot data. Okay, so other dot data. So now we are return. Okay, return out. Okay, now we return out. Okay, so this is our output. Okay, so now I am a b equal to va value val ue value 1. So value 1 10. This is b. Okay, so now I c is equal to, otherwise simply was a plus b. So we'll see the a plus b. Okay, so now a plus b is simply addition of 10 plus 10. Okay, so simply addition of 10 plus 10. Now I want to save. This is our ultimate purpose of this, is because we have to create our nested object. So here I want to save my, so this out object is, so I want to, here I want to save this out object is this out object is created by these two objects. So, okay, so this self and other. So now I should save this object. Okay, so for this I should say children, children. Okay, by default this is the empty tuple. Okay, this is self dot. Okay, this is ILTRE previous. Okay, previous. Here I will set CHILTRE children. Okay, this is our children. Okay, this is our children here. Okay, so now we can see we have to send here that previous. Okay, this is the tuple. Okay, self and other. Okay, self and other. We are sending these two here. Okay, so now if we enter here. Okay, so here we can see a plus. Okay, now we define c is equal to a plus b. Okay, a plus b c dot. Okay, underscore here previous. Okay, you can see c dot previous here equal to the two values. Okay, value of 10. Okay, now we have. Okay, next we have to save all these operations. Okay, next we have to save this operation of here operation. So this is empty string. Okay, here sclf self dot underscore op equal to op here in operation. Then we are going to save all the labels. Okay, these operation and label are only for this kind of. Okay, only for to represent these values. Okay, so for this only we are using the labels. By using the labels we are storing these variable names. Okay, variables names and operation names. Okay, so this is by using operation label, using label dot equal to label. Okay, so here we are passing our here. Okay, this is our class label label. Okay, label equal to empty string and operation and label. Okay, so here okay, op is equal to operation and labels equal to label. So here a dot label equal to a. Okay, b dot label equal to b. Okay, here c dot label equal to c. Okay, now we will see the c dot label. Now here c dot label is nothing but sc. Okay, and then we have. Okay, now and we will see our already we have seen our previous and everything we have seen. So this is ABC, and then we will send here. Okay, send again. This is our operator. Okay, so then. Okay, so this is then we are using here two functions. Okay, this function is the trace function is the so simply this is a recursive. Okay, transfers. Okay, transfers recursive logic used here. So this using the trace. Okay, so if you give our nested object, okay, we will get the flat all our node list. Okay, it will return our node and list in a set. Okay, by using this one. Okay, by using this trace. Okay, we will get everything we will get the list of our nodes, and by using this draw dot. Okay, this draw dot function, and by using our this draw dot function we are generating this graph. Okay, we are generating this kind of graph. Okay, so now I am going to. Okay, this is our c. Okay, this is our c. Okay, here I am putting our c. Okay, here I am putting our c. Enter. Okay, you see b. Okay, so this is a plus b give us c data. Okay, so this is our result. Okay, so I uploaded this entire notebook. So and I have given some other examples. Okay, I have given some other examples. So I am going to upload this one. Okay, this I will give this link. Okay, this link in our video comment section. Okay, this comments and description section. Okay, so you can get these links. Okay, you will whatever the change you need, you will change, and you will just reproduce this entire code. You will get a clear idea, and and you know how to create this kind of computational graphs. Okay, thank you. We will see next video.